Hi friends, hope you're all doing fine. So this is our 7th session in microeconomics. In the last session we studied about demand for a commodity, law of demand, demand curve and some related concepts. In the demand curve we studied that it will show the various quantities of a good which people will demand at different prices. Now if initially at a price we will know how much the people are demanding. If the price were to increase, then also we may be able to find out how much will the people demand. Suppose we are interested to know how much will the people demand if the price were to increase at a higher rate or if the price were to decrease at a given proportion. So how will we find? Here is where we introduce a new concept, which is elasticity of demand. In this session, we will focus on elasticity of demand as well as a few numerical examples to understand the process of computing elasticity of demand. First of all, what is elasticity of demand? Elasticity of demand refers to the measure of responsiveness of quantity demanded of a commodity to a unit change in any of the factors influencing it. Symbolically, it is given as percentage change in quantity demanded by percentage change in base factor. Now, base factor can be any of the factors influencing demand for a commodity. It can be price of the good, price of related goods, and income of the consumer. See, there are other factors as well, taste and preferences and future price expectations of consumer. However, these cannot be quantified and therefore we cannot measure elasticity of demand with respect to these factors. However, the most common and most prominent sort of elasticity of demand is the price elasticity of demand. What is it? Price elasticity of demand refers to the responsiveness of quantity demanded of a commodity to a change in own price of the commodity. Now, the absolute value of coefficient of the price elasticity will be from 0 to infinity. We are not considering the sign of elasticity here. The elasticity coefficient's absolute value will be from 0 to infinity. The sign, if you ask me, it is negative generally. Why? Because of the inverse relationship between price and quantity demanded as given by the law of demand. But there are a few exceptions, prominent of them being the Giffen paradox. In given goods, as price increases, quantity will also increase. So for them, price elasticity will be positive. Now there are few degrees of price elasticity. First of all, the perfectly inelastic demand. Here, whatever be the price change, let it change extremely, even then quantity will not change. It will remain constant. In such a situation, we term elasticity to be perfectly inelastic demand. Now, the next degree is inelastic demand. Okay, what is this? Here, quantity demanded will change as price changes, but the proportion of change in quantity will be less than the proportion of change in price. Here, elasticity will be between 0 and 1. Then the third category is unitary elasticity. Here, percentage change in quantity will be equal to percentage change in price. Whatever be the proportion of change in quantity, means change in price, quantity will also change in the same proportion. Here, elasticity will be equal to 1. Then we come to elastic demand or more than unitary elastic demand. Here, proportion of change in quantity will be greater than proportion of change in price. Okay, here elasticity will be greater than 1. Then we come to the final degree, the perfectly elastic demand. Here what will happen is, at at the same price, the quantity will change infinitely. So what will happen? Elasticity will be infinity. For the same price with no change in price, quantity will change infinitely. Then there are a few factors which influence elasticity of demand. First of all, it is the availability of close substitutes. Let's take an example of tea and coffee. What will happen? If price of tea rises, people will immediately shift to coffee. So if there are close substitutes, elasticity will be higher. Okay, then we come to the income of consumer. If consumer is a wealthy person, elasticity of demand will be less. For if the price rises, consumer can still afford to buy a sufficient quantity of the commodity. However, for poor people, if their income level is less, elasticity will be more. Then we come to the nature of the good, luxuries versus necessities. What will happen here? In case of luxuries, elasticity of demand will be high. In case of necessities, elasticity will be low. Why? Because people cannot do without consuming necessities. Then we come to the price range of the commodity. If the commodity is highly expensive or falls in the high price range, or it is very cheap and falls in the lower price range, elasticity will be less. However, for all commodity with range between these two, elasticity will be more. Then there is the factor of proportion of income spent on the commodity. If a major portion of consumers' income is being spent on the given good, elasticity will be more. If the proportion spent is very meager, then elasticity will be less. Example, common salt. Generally, people spend only a meager or a minute part of their income on common salt. So, it will have relatively inelastic demand. Then we come to the point of time period. What is it? If the people have longer time to adjust to the price change, elasticity will be more. Let's take an example of petrol. If price of petrol rises, in the short run, what can you do? You can take fewer trips, but can you do anything else? Can you totally avoid taking trips? No, you can't. But in the long run, either you can buy a vehicle with smaller engine capacity, or you can shift to a new consumer habit. Next, we come to the factor of number of uses of the commodity. Take an example of milk. Milk has many uses. So if price of milk falls, people will immediately put it to many other uses. Okay. So if number of uses of the commodity is high, naturally elasticity will be more. Then we come to the habits of the consumer. If consumer is accustomed to the good, or if the habitual consumer of the good, elasticity will be more. Elasticity will be less. Why? Because the consumer cannot do without the good. Then we come to the factor of tight demand. Take an example of ink. To consume ink, we need pen. Okay. Or to consume pen, we need ink. Both are true. So, if the price of ink changes, there will be very less change in quantity. Why? Because the price of pen has not changed. So, demand for goods which are tied to others will be less. Next, let us come to the methods of measuring price elasticity. Before we go to the formulas or the methods, let us first understand a few symbols. Okay. Q0 generally means the initial quantity demanded of a good, and Q1 means quantity demanded after price change or new quantity demanded. P0 means the initial or original price of the good, and P1 will be the altered or new price of the good. Delta Q Q1 minus Q0 or new quantity minus old quantity. And delta P naturally P1 minus P0, new price minus old price. Next, let us discuss the methods to measure price elasticity of demand. The first method is the percentage method or the proportionate method. According to the percentage method, elasticity of demand or ED equals percentage change in quantity divided by percentage change in price. Symbolically, percentage delta Q divided by percentage delta P. According to the proportionate method, elasticity equal to delta Q by delta P into P by Q. Here P is equal to initial price and Q is equal to initial quantity. Then we come to the total outlay method or the expenditure method. Here, if the price of the good rises and if total outlay or expenditure on the good rises, then we say demand is relatively inelastic or ED less than 1. If price of good rises and outlay remains unchanged, we say ED equals 1 or unitary elastic. If price of good rises and outlay falls, we say demand is elastic or ED greater than 1. Then what will happen if price of good falls? Exactly the opposite, right? If price of good falls and outlay rises, we say that demand is relatively elastic, ED greater than 1. If price of good falls and outlay remains unchanged, ED equals 1. And if price of good falls and outlay also falls, we say demand is relatively inelastic. Now let us discuss some numerical examples. First question, find out elasticity of demand for good X if initial price and quantity are rupees 5 and 10 units. When price changes to rupees 6, quantity becomes 7 units. So as price increased, quantity fall. So what's the solution? We know P0 is equal to rupees 5 and P1 is equal to rupees 6. Q0 is 10 units and Q1 is equal to 7 units. For the sake of maintaining order, let us first focus on percentage method to compute elasticity. So what is percentage delta P? Percentage delta P is equal to P1 minus P0 by P0 into 100. Okay, so we know. First, let us focus on quantity. Percentage delta Q will be equal to Q1 minus Q0 by Q0 into 100. That is 7 minus 10 by 10 into 100 is equal to 30%. Now, percentage delta P will be equal to P1 minus P0 by P0 into 100. Is 6 minus 5 by 5 into 100 is 20%. So, we know from the formula of elasticity ED equals percentage delta Q divided by percentage delta P, which is minus 30 by 20 is equal to minus 1.5. So, what do we infer? That the demand for the given good is relatively elastic in nature. Okay. Now, let us focus on one more question. Find out, okay, out of income of rupees 100, Mr. X spends rupees 50 on good X when the price was rupees 5. And when price rises to rupees 6, Mr. X spends only rupees 42. So here we are asked to comment on elasticity of good X for Mr. X. Okay, so what? We are not asked here to compute the value of elasticity. We are just being told to comment. So what we do? We use simple expenditure method. We only need to know whether demand is elastic, inelastic, unitary elastic, perfectly elastic or perfectly inelastic. Okay, so how do we do that? Solution. Here what happens? Price rises from rupees 5 to 6, right? Price rises from rupees 5 to 6, right? Implies price rises, increase. Okay, what happens to outlay? Because we are only computing the outlay method. Outlay. Outlay. What is about the outlay? Initially, when the price was rupees 5, Mr. X was spending rupees 50 on the good, right? And when price rose to rupees 6, Mr. X spends only rupees 42. Outlay from 50 to 42 to 42 means outlay falls. Right. Price rises and outlay falls. What does this mean? In expenditure method, we have studied when the price rises, if outlay rises, then demand for the good is relatively inelastic. Price rises, outlay constant, then demand is unitary. Price rises and outlay falls. Therefore, by outlay method, price rises, outlay falls. ED greater than 1 by elastic. Okay, elastic demand. Got it? See, if they are asking us to just comment, we need not compute the absolute value of elasticity. We are just commenting whether elasticity is perfectly inelastic or relatively inelastic, unitary elastic, relatively elastic or perfectly elastic in nature. Now we are going for another question. Given the following information, okay, compute price elasticity and arc elasticity. So initial price is equal to rupees 8 and initial quantity is 15 units. New price is equal to rupees 6 and new quantity is 30 units. So what do we get? Okay, now first of all let us use compute price elasticity. Solution. Now we'll just jot down what we have. P0 is equal to rupees 8 and P1 is equal to rupees 6. Okay, now Q0 is equal to 15 units and Q1 is equal to 30 units. So now we will compute delta P and delta Q. We are not computing percentages, okay? Delta Q is equal to 30 minus 15 is equal to 15 units. Okay. So delta Q is 30 minus 15 is equal to 15. Now what about delta P? Delta P is equal to 6 minus 8 is equal to minus 2. Okay, delta P is minus 2. From proportionate method, we know ED equals delta Q by delta P into P by Q, right? So we have all the measures. Delta P is minus 2 and delta Q is 15 units, right? So what we have? Delta Q by delta P into P by Q. We know P initially was 8 rupees and Q initially was 15 units. So what we have? Delta Q by delta P into P by Q. Delta Q is 15 divided by minus 2. Okay, delta Q by delta P into 8 by 15. So what will happen? That elasticity will be minus 4. Okay, so now we have all the measures, right? But there is one more question. We have to compute arc elasticity. See, I know arc elasticity is a new concept. Okay, first of all, let me note what we have. Okay, we know everything, right? Delta Q is equal to 15 and delta P is equal to minus 2, right? So what will happen? Arc elasticity of demand or arc ED, the formula is delta Q by delta P into P1 plus P0. The formula for arc elasticity, as we have discussed, delta Q by delta P into P1 plus P0 by Q1 plus Q0. Okay, this is just a refined measure of elasticity. So what is arc ED? In our example, which we did before, delta Q is 15 by delta P is minus 2 into P1 plus P0 means 6 plus 8, 14 by Q1 plus Q0 means 15 plus 30 or 45. Okay, is equal to minus 14 by 6. Okay, which will be equal to minus 2.33. We got price elasticity as, I think, price elasticity as minus 4 and arc elasticity is minus 2.33. There will be a small difference between the two. So this is all with reference to this session. Here we have discussed the concept of elasticity, degrees of elasticity, factors affecting elasticity and measuring elasticity, and we have also discussed some numerical questions. So friends, I will be meeting you in the next session. Till then, bye bye.